Lesson 8, which variable to solve for? Part 1, learning target. Given an equation, I can solve for a particular variable, like height, time, or length, when the equation would be more useful in that form. In this lesson, we learned how to solve for a variable. Rearranging an equation to isolate one variable is called solving for a variable. Let's look at 3 different equations to demonstrate how to solve for a variable. Our first equation is a equals 3b. How might we rearrange this to solve for b? To isolate b, we first need to divide both sides by 3. This means that a thirds equals b. Remember that a fraction means the same thing as division. Our next equation is n times l equals 2. How might we rearrange this equation to solve for n? We need to divide both sides of the equation by l. This gives us an equation n equals 2 divided by l. Again, remember that a fraction means the same thing as division. Our last equation is 124 plus 9m equals p. This equation has more operations than the other 2, so this means we'll have a few more steps to rearrange to solve for m. Our first step is to isolate the term that has the variable 9m. This means we need to subtract 124 from both sides. When we do, this means that we have 9m equals p minus 124. Lastly, we must divide both sides by 9 to isolate m. Notice that we need to divide the entire right side by 9, so we would put parentheses around the expression p minus 124. This means that our last equation is now m equals p minus 124 divided by 9. All 3 of these rearranged equations are equivalent to the original equations. A relationship between quantities can be described in more than one way. Some ways are more helpful than others, depending on what we want to find. Let's look at the angles of an isosceles triangle, for example. In this diagram, we see that we have 2 bottom angles labeled A, and the remaining top angle labeled B. The 2 base angles, which are the ones near the horizontal side, have an equivalent measure in degrees and therefore are both labeled A. Since the angles in a triangle add up to 180, the relationship is A plus B equals 180. Let's use the angle relationship from the previous slide to find different angle measurements in the isosceles triangle. First, we're going to find when B equals 20. Remember from the previous slide that A plus B equals 180, because all the angles in a triangle sum to be 180 degrees. We can substitute 20 in for B, which means our equation now is 2A plus 20 equals 180. Remember that we're trying to solve for A, so we're going to subtract 20 from both sides. This leaves us with 2A equals 160. Lastly, we need to divide both sides by 2, which gives us A equals 80. Now let's find A when B equals 45. Remember, we start with A plus B equals 180. Now we can substitute 45 in for B, which means our equation now becomes 2A plus 45 equals 180. Remember that we're going to try to solve for A, so now we must subtract 45 from both sides, leaving us with 2A equals 135. Lastly, we need to divide both sides by 2, which gives us A equals 67.5. On the previous slide, we solved both examples for A. Now we're going to look at 2 examples where we are asked to find B. First, we're going to find B when A is 34. Since we're still referring to an isosceles triangle, we'll continue to use the relationship A plus B equals 180. We can substitute 34 in for A, which means our equation becomes 34 plus B equals 180. We combine our 34s and we come up with 68 plus B equals 180. Lastly, we need to subtract 68 from both sides, leaving us with B equals 112. Next, we're going to find B when A is 72.5. Since we're still referring to the isosceles triangle, we'll continue to use the relationship A plus B equals 180. We substitute 72.5 in for each of the A's, and it's 72.5 plus B equals 180. Combine our 72.5s, we get 145 plus B equals 180. Lastly, we need to subtract 145 from both sides, which gives us B equals 35. Notice that when a is given, we did the same calculations repeatedly to find b. We substituted a into the first equation, combined like terms, and then subtracted the results from both sides. On the next slide, we'll look at a more efficient strategy for doing this type of problem. Instead of taking these steps over and over, whenever we know one variable and want to find the other, we can rearrange the equation to isolate each variable. Let's first rearrange the equation to isolate a for cases where we know b and want to find a. We can combine the a's to have 2a plus b equals 180. Then we'll take b away from both sides, so that leaves us with 2a equals 180 minus b. Lastly, we need to divide both sides by 2, so we're going to come up with a equals 180 minus b, parentheses, divided by 2. This equation is equivalent to the first one. To find a, we can now simply substitute any value into b into this equation and evaluate the expression on the right side. Likewise, we can rewrite an equivalent equation to make it easier to find b when we know a. Let's rearrange the equation in the right column to isolate for b. On this side, we want to get b by itself, so we can combine like terms and have 2a plus b equals 180. In order to isolate b, we know we need to subtract 2a from both sides, so we're going to have b equals 180 minus 2a. All three of these equations, a plus b equals 180, a equals 180 minus b divided by 2, and b equals 180 minus 2a are all equivalent. Depending on what information we have and what we're interested in, we can choose a particular equation to use.